So this is the first section of chapter 1 from D2, which is all about transportation problems. And this section, we go through the northwest corner method. So first of all, what are these transportation problems? Well, what we have is suppliers. Now, these are the people that have stock stored away somewhere, ready to send to depots or destinations. And these destinations want particular amounts of stock from their suppliers. And one of the things we need to do is to make sure that, there's enough stock here to go to these different destinations. But what we're really interested in is the cost involved in transporting stock from the suppliers to the depots. And we're going to be using algorithms that allow us to minimize the cost of transportation. So we want to minimize this cost or the costs of transporting the stock from the suppliers to the depots or destinations. And our first step is finding what we call an initial or feasible solution. And that's where this northwest corner method comes in. Now, I'm not going to go through all the steps of the algorithm here, because that can be long and tedious and you may still not understand what to do. So I'm going to go through an example and go through the steps of the algorithm in an example. So example 1, 3 suppliers A, B and C. So you can see the suppliers are listed here at the side. Each produce road grit that has to be delivered to council depots W, X, Y and Z. So let's have a look at the table. So we've got these suppliers here. And the last column here tells us how much stock each of those suppliers has. Okay, so these numbers here represent the amount of stock held by the suppliers. So I can see that supplier A has 14 units of stock, supplier B 16 units of stock, and supplier C has 20 units of stock. We'll come to the numbers in the middle of the grid in a moment. So what I'll do is I'm just going to highlight these numbers. So these numbers in the center don't tell us about the amount of stock, but we'll come to that in a moment. And we're told in the question that they need to deliver this grit to these council depots, which are listed here. So our stock needs to go from the suppliers to the depots. Now the numbers at the bottom here represent how much stock each of the depots needs. So I'll just highlight that. So these numbers here represent the amount of stock each depot needs, or depot or delivery point needs, each depot needs. Okay, and then the number in the bottom corner here basically is the total of the stock and the demand, and we should expect these numbers to match, and they do. If I add these up here, come to 50, and these numbers here add up to 50. Now the numbers in the middle represent the costs. So these numbers here, these are the costs of transporting the stock from one depot to another. So these are the transportation costs. Transportation costs. So basically what that means is, if I want to take 1 unit of one lorry load of grit from supplier A to depot W, 1 lorry load of grit is going to cost 180, let's call it pounds, or 180 units of money. So if I got all 11 of my lorry loads of grit from let's say supplier A, then that's going to cost me 180 times 11. So now we know basically how this table works, with our suppliers listed here and how much stock they hold, and our depots listed here and how much stock they need, and the numbers in the middle here representing the cost of transferring 1 unit of stock. We can now answer the questions. So we start with part A, and part A says use the information table to write down the number of lorry loads of grit that each supplier can supply. So supplier A can supply 14 lorry loads of grit. Supplier B can supply 16 lorry loads of grit, and supplier C can supply 20 lorry loads of grit. Part B, we want to write down the number of lorry loads of grit required at each depot. Well, depot W requires 11 lorry loads of grit. Depot X requires 15 lorry loads of grit. Depot Y requires 14 lorry loads of grit, and depot Z requires 10 lorry loads of grit. And we can see by adding these up, and the same as what we have in the table, that the supply matches exactly the demand. We have a supply of 50 lorry loads of grit, and we have a demand of 50 lorry loads of grit. Part C, we need to write down the cost of transporting a lorry or one lorry load of grit from A to W. So we look in the table like a cost matrix here. So it's going to be this value here. And when we write down the cost, we can just write down what the cost is, or we can write down C for cost of transferring A to W like this, or we can write it C for cost of transferring from A to W like this, and then we'll write down 180. Oh, and it does say in the question that the cost is in pounds, so I'll change that to 180 pounds. Then I'll move on to part D, and part D is asking us to find out the cost of transporting a lorry load of grit from C to Z. So from C to Z, that's going to be this one here, 120. So I'm actually going to write it like this, cost CZ, like that. I prefer writing the subscript way, and that's going to be 120 pounds. Part E, which is the cheapest route to use, so we're looking for the lowest cost in this cost matrix here, and that looks like it's going to be 110 pounds. So that's when we're transferring something from supplier A to depot X. So that's going to be supplier A going to X, and they're only charging 110 pounds per lorry load. Now that may be because it's closer, it may be of a lower quality. We're not really concerned about that. As I said, as we work through this chapter, we want to minimize our cost. And then lastly, part F, nice and straightforward, the most expensive route to use. So I see 290 looks like the highest. So that's supplier A to depot Z, and that's going to be 290 pounds. So example 2, what we want to do is to use the northwest corner method to find an initial solution to the problem described in example 1, which is this problem here, shown in the table, and state its cost. So this is the bit where we're going to use this northwest corner method algorithm. So I've drawn a blank table here. We're going to use this blank table here, and the first thing that I need to do is to copy down the stock and demand columns and leave the rest of the table blank for the moment. So my stock is going to be values of 14, 16, 20 and a total of 50, and my demand is going to be 11, 15, 14 and 10. And I also need to add, I'll just write W, X, Y and Z to represent my depots, and suppliers A, B and C to represent my suppliers. Now this algorithm probably isn't going to give us the cheapest overall cost, but it's going to give us a starting point, what we call an initial or feasible solution. And this is how it works. So I'm going to start in the top corner here, a supplier A and depot W, and I see that depot W needs 11 units of stock. So basically I'm going to say, right, I'm going to take 11 units of the stock from supplier A and allocate it to depot W. So I'm going to use 11 there. So that now supplies the demand for depot A, but it hasn't used up all the stock. Sorry, this has supplied all the demand for depot W, but this hasn't used up all the stock of supplier A. Supplier A still has 3 units of stock. So what we'll do is we'll give those 3 units of stock to depot X. Now depot X requires 15 units of stock. They've only got 3. They need another 12 units of stock, which I can grab from supplier B. So I'm going to put 12 down here. So now depot X has its supply met, and I suppose I can put a tick at the side here to say that I've used up all the stock of supplier A. So W's happy, X is happy. We now move on to Y. Now when we move on to Y, we've only used up 16 units of stock from supplier B, so we're going to give the remaining stock to depot Y. So that now means all of this stock is exhausted. However, depot Y doesn't have everything it needs. It needs another 10 units of stock to make it up to the 14. So I'm going to grab 10 units of stock from the next supplier down. Now you may see why this is called a northwest method. We start in this top corner here in the northwest and move down to the southeast. So it's like a diagonal thing as we move across. So now supplier Y, depot Y has everything they need. I've used up 10 units of stock from supplier C. They have 10 units left. So that 10 is now going to go to depot Z. So I've used up all the stock in supplier C, and now supplier or depot Z now has all its demands met. Now because these two totals agree, everything gets used up. I haven't got anything left over. So this is our northwest corner method. You start in this top corner, you give as much stock as you can to the first depot. That means there may be some stock left over to give to the next depot, and so on, and we keep carrying on until basically all of the stock is used up and each depot or delivery point or destination has their sort of supplies met. Now we want to now find the cost of all of this. Now this is where we now look at the middle part of the table, this cost matrix part here, and this will tell us how much it's going to cost for 1 unit. So our overall cost, so I'm transporting 11 units here and each one cost 180. So that's going to be 180 times 11, or 11 times 180. That first box, what I'll do is I'll highlight them as I go along so you can see which ones I've used. Actually, let's highlight them now. So basically, these are the costs that I'm interested in, because these are the supply routes that I'm using. So yeah, 11 times 180. Then I need to add 3 times 110. That's the next box along. If I go down one, then I need to add 12 times 250. And then I'm going to add to that 4 times 150. And then 10 times 190. And then the very last box is going to be 10 times by 120. And just work out that total. And that's a total overall cost of £9,010. So you should now be able to do exercise 1A on pages 5 to 6, and I've got the algorithm sort of written out here, which you can refer to, but I think actually it's more straightforward to actually look at the example and use that to help you work it out rather than try and memorize these steps here, but it's here if you need it.